Additional Mathematics Paper 1. And the AdMath Paper 1, it started in 2012, and so there is no paper before this date. So with that being said, let's start. So the first question says, the expression x minus 2 is a factor of which one of these expressions? All right, so to find out if it is a factor, if x minus 2 is a factor, we go to factor theorem, and factor theorem that if x minus 2 is a factor, then f of 2 equals 0. So we need to see which of these will give us f of 2 being equal to 0. So you're going to substitute x as 2. All right, so we're plugging in x equal to 2 and see which one gives us 0. We'll plug in x equal to in the first one, we get 4 times 2 to the 4, which is 64 minus 2 times 2 squared minus 56, and that's 0. This one gives us 0, and so it is option A. 4x to the 4 minus 2x squared minus 56. When you plug x as 2, you get 0. So that is option A. All right, nice. Second one, it says the expression AB plus 3C minus 3B minus AC can be equal to. So what we need to do then now is, well, we're going to factorize this expression. What we can is group AB. We can group AB with minus 3B, and then we have, or we can group C. Let's group those two first, and then we have plus 3C minus 3B. Let's group those first. So right here, we can factor out A, and we're left back with B minus C. And then from this side, we can factor out a positive 3. And let's factor out minus 3. Factor out minus 3, we're left back with B minus C. And so this expression simplifies to be A minus 3 times B minus C. That's how we do that one. Yes. All right, the third question. The third question says, which of the following graphs best represents f of x equal to x times 1 minus x? First and foremost, as you can see, if you're to expand this function, what you're getting is x minus x squared, x minus x squared. And if you're to put that in standard form, what that means is that the first term or the coefficient of x squared is negative. And so automatically we know that it frowns. We know that it frowns. What else do we know? We know that right here, when x is equal to 0 and x is equal to 1, those are the roots. These are the roots. The roots are 0 and 1. So we look for a frown with roots 0 and 1. That is option B, right? And that takes care of this question. Number 4. It says the number of visas issued by an embassy annually is given by V of x is 7x squared minus 42x plus 72. The least number of visas issued in a particular year. To find the least number of visas, you need to find the turn, you need to complete the square and find the y value at the turning point. That will be the least number of visas. This is a quadratic function. Quadratic function looks something like this. All right, and then this would give us the least number of visas. That's how a quadratic looks. So we need to find this y value at the turning point. So we need to complete the square. So to complete the square, all right, many of us learn it as k, and we find k as, k is given by the formula 4ac minus b squared, 4ac minus b squared divided by 4a. That's the formula we learned to find k, all right? And so what you do now is you go ahead and remember a is 7, the coefficient of the x squared, a is 7, c is 72, and b is minus 42. So you go ahead and you work that out. You have 4 times a, which is 7. So 4 times 7 times 72. 4 times 7 times 72. Okay, let's make some space. I want to make some space for this one. So this is the formula we're using. Let's see if we can. All right, so 7x squared. Let's go to a blank sheet so we have enough space. All right, this is better. So we had 7x squared minus 42x plus 72. And this is equal to 0. All right, and this is v of x. And we're finding the y value at the turning point. And so we use the formula. So we were getting k is equal to 4ac. So it's equal to 4 times 7. 4 times 7 times 72. That's 4 times a times c minus b squared, which is minus 42 squared over 4 times a, which is 4 times 7, which is 28. All right, this 28 comes from 4 times 7. So let me put that so we're not confused. 4 times a, which is 7. So we go ahead and work it out, and that will give us the least number of visas. So it's 4 times 7 times 72 minus 42 squared divided by 28, which equals 9. All right, so all that means is if you're to draw the quadratic to represent this function, all right, it looks something like this. It cuts the y-axis at 72. And this y value right here is 9. This is the least number of visas. All right, and it occurs in this particular year. All right, when this particular year. To find this value, this is just the x value at the turning point. All right, this is just the x value at the turning point. So the least number of visas is 9. This is the answer, 9. All right, it says now the roots of the equation are, to find the root, to determine the nature of the roots of the equation, you work out the discriminant. The discriminant is given by the formula b squared minus 4ac. That's the discriminant. That gives you the nature of the root. Work out b squared minus 4ac. All right, and so b squared is just going to be, b is 6, so it is 6 squared minus 4 times 5 times negative 2. So we go ahead and work that out. That's negative 2. Don't like how it's scribbled up right here. Let's try to make it a little better. 4 times 5 times our negative 2 That will equal to 4 times 5 is 20. 20 times -2 is -40. And I'll just put it in the calculator to make it easier on us. I'm getting 76. Since I'm getting 76, it means that the roots are real and distinct. So the roots are real and distinct. Nice and easy, soft. Now, this question now says, find the set of values of x for which 5x plus 7 is greater than 10x minus 13. All we have to do now is group the x on one side. So we're going to bring the 13 over here. We're going to add 13 to both sides first to get 5x plus, when you add 13 to both sides, you get 5x plus 20. And 5x plus 20 is now greater than 10x. Then what we're going to do next is we can, all right, so we can subtract 5x from both sides to get 20 is going to be greater than 10x minus 5x is 5x. And then we divide both sides by 5, and so we get x look like it is less than 20 divided by 5 is 4. And so 4 is greater than x, and some people might write it as x is less than 4. All right, this is the same thing. X is less than 4. All right, and so that looks like option C. X is less than 4. And you can test it. For a value like 3, you would get 5 times 3 plus 7, which is 22. And 10 times 3 minus 13 is 17. And it is true. So that's how you do that question. All right, now this question says, find the range of values of x for which 5x plus 6 is less than or equal to x squared. So to do this, we're going to get a quadratic inequality. We can bring over on one side. So I'm going to subtract 5x and 6 to get 0 is less than or equal to x squared. When I bring over the 5x over here, it becomes minus 5x. And I bring over the 6, it becomes minus 6 right here. And so now what I really have is, this is really saying x squared minus 5x minus 6 is greater than or equal to 0. So what we have is a quadratic, and we factorize it. Let's go ahead and factorize. This means signs are different and the greater product negative. So we have a 6, and a minus, and a 1, and a plus. And to get x squared, it has to be x and x. All right. And so what we have is a quadratic that looks something like this. The roots are minus positive 6 and minus 1. Then I get as positive 6 and minus 1. This is the root minus 1. This is the root positive 6. And it wants the portion of the graph that is greater than 0, that is outside here. This is the part of the graph that they want. That's the part of the graph that they want. And so the solution is going to be, this shaded portion is x is less than or equal to -1, or this part of the solution is where x is greater than or equal to 6. So let's look for that. X is less than or equal to -1, or x is greater than or equal to 6. That is option B. Nice. Moving right along, it tells us that f of x is equal to 3x minus 4, and f g of x is equal to x, then g of x is, now listen, now if f g of x is equal to x, then what they're telling you is g of x is equal to f inverse of x. G of x has to be equal to f inverse of x. That's what they're telling you. Anytime Anytime you have g f of x equal to x, then that means this inner function is the inverse of the outer function. That's the only way you can get back the domain x. And so, since g of x is f inverse, we're just finding f inverse. To find f inverse, you have y, call f of x y is equal to 3x minus 4. And then to find the inverse, the first thing we're told is to interchange x and y. And so x is equal to 3y minus 4. And then we make back y the subject. To make y the subject from here, we add 4 to both sides. So we get x plus 4. And then we divide x plus 4 by 3. And that will give us y. Nice, that will give us y. Since that will give us y, x plus 4 over 3, that looks like option B. Nice. All right. Now the next question says, the table below, or the tables below, show the set of ordered pairs and for two functions, f and g. So this table is for f, and this table is for g. And they say find the value of g inverse f of 3. So the first thing I would like you to do is find what is f of 3. So this is when x is 3. So I look when x is 3, and that is 2. So that means that f of 3 equal 2. That's the first thing we realize. When x is 3, we get that f of 3 is equal to 2. All right, good. So now what this part want now is g inverse of 2. So we need to find g inverse of 2. Now, in other words, if you're trying to find g inverse of 2, then what they're asking you to do is, in translation, we're solving g of x equal to 2. All right, this is what they're asking you. When is g of x equal to 2? G inverse of 2, in other words, they're asking you to solve g of x equal to 2. These are the same. And so we look when g of x is 2, which is right here, and look at the corresponding value for x. That x value is 5. And so that means the g inverse of 2 is 5. All right? Because if this is g of x, if you were to sketch the inverse function, if you were to write up g inverse function, you would interchange x and y. All right? And so we get the x value is 5. Moving along, question 10. Question 10 says that a function h is defined by h of x is 5x plus 2. Expressed in terms of h of 2a plus 3. So we want to find h of 2a plus 3. So we're going to replace x right here with 2a plus 3. So we're going to get 5 times 2a plus 3. Notice what I did, I substituted x as 2a plus 3. Plug in 2a plus 3 into x. I get 5 times 2a plus 3 plus 2. And so 5 times 2a is 10a. 5 times 3 is 15. And then I have plus 2. 15 plus 2 is 17. That part is just 17. And so I have 10a plus 17. And that is this right here, 10a plus 17, which looks like option C. Nice. That takes care of question 10. Moving along. Right here, it says that we need to find what is a function f is defined by f of x is 2x minus 1. And they want the function f squared. Now, when they say f square means f of x. That's what f square means, f of x. F of x means you put f of x into f of x. So you're going to get 2 times f of x is 2 times 2x minus 1 minus 1. This is f square. F square means f of x. F square means f of x. So you work out what is 2 times 2x minus 1. 2 times 2x is 4x. And then you have 2 times minus 1 is minus 2. Minus 1, that's minus 3. So you get 4x minus 3, which is option D. Nice and easy. Soft with a capital T. Now this right here asks us to find the nth root of 3 times 27 to the m. To do that, we have to remember that 3 is really 3 to the 1 times 27 is 3 cubed. So it becomes 3 to the 3m. And then the nth root can be written as everything raised to the 1 over nth power. This is to the 1 over n. Now, when the bases are the same, we know we can add the power, so it becomes 3 to the 1 plus 3m. And all of this is raised to the 1 over n. Yeah, man, all of this is raised to the 1 over n. And so all you have now is this becomes 3 to the 1 plus 3m, 3 to the 1 plus 3m over n. That's it. That looks like option A. Nice and easy. So that's a simple indices question here. Nice. All right, let's look at this question now. Question 13. It says 8 plus root 5 times 2 minus root 5 can be expressed as. So you're just going to expand the brackets. 8 times 2 is 16. 8 times minus root 5, that becomes minus 8 root 5. Minus 8 root 5. Then you have 2 times root 5, that becomes plus 2 root 5. And then you have root 5 times minus root 5, that becomes minus 5. Now, of course, you learned from Csec math that 6, you group like terms. So 16 minus 5, you group them and you get 11. Those are the two like terms. And minus 8 root 5 plus 2 root 5, minus 8 plus 2 is minus 6. That becomes minus 6 root 5. So the final answer is 11 minus 6 root 5. Again, the why? Because we group like terms. 16 and minus 5, those are like terms. And minus 8 root 5 and plus 2 root 5 are the next like terms. Nice. All right, question 14. Question 14 said 2 to the z. Find the value of 2 to the z, where z is equal to 5 plus, where z is equal to 5 plus the log to base 2 of 3. And we need to find the value of 2 to the z. Okay, so if this is z, all right, this is z. What I'm going to do is I like to write it as 1 logarithm. That's just for me. Since I have it as base 2, all right, this 5 right here, I can rewrite this 5. This is just how I would do it. There are many ways you could. I'm going to rewrite 5 as, 5 can be written as 5 is the same as 5 log 2 of 2 plus log 2 of 3. Log base 2 of 3. All right. And then now, by laws of logarithm, I can carry up the power. And carrying up the power, I get log base 2 of 2 to the 5th plus log base 2 of 3. Now, what I can then do next is, by laws of logarithm, we know that we can add log A plus log B is the log of AB. So this becomes log to base 2 of 2 to the 5th times 3. Now 2 to the 5th is 32 And 32 times 3 is 96. So I get log base 2 of 96. All right, nice. So that is what we have now. Now, this is just z. Z is equal to this. All right, z is equal to log base 2 of 96. So we need to find 2 to the z now. All right, so we need 2 raised to this power. That would give you 2 to the z. All right, but look how I'm going to do this, because we're getting some actual values here, if you notice. So I'm going to write this in terms of base 10 because I don't know what these values are. Log base 2 of 96. Write this in terms of base 10 using the change of base law. This is just going to be the log of 96 divided by the log of 2. That's what z equal now. The log of 96 divided by the log of 2. And I'm getting 6.6. That is z. Z is 6.6. So since z is 6.6, then 2 to the z is equal to 2 to the 6.6. 2 to the 6.6. And so we work that out now, and you get 96. 2 to the 6.6 is 96. And so this is your answer, C. Nice and easy, soft. So remember right here, what we did first was simplified z. This is z. And we found that z is 6.6. And then we found 2 to the z. You have to find z before you can find 2 to the z. Nice. All right, question 15. Question 15 says the expression root 5 minus 1 over 1 plus root 5 when simplified is equal to. So this expression right here, what is it equal to when you simplify? To simplify it, you need to rationalize the denominator. So we have root 5 minus 1 over 1 plus root 5. And to simplify it, you need to multiply by the conjugate of the denominator. And the conjugate of the denominator is 1 minus root 5. So we multiply it by 1 minus root 5. All right. So we multiply both the denominator and the numerator by 1 minus root 5. That is what we do. Since we multiply both the denominator and the numerator by 1 minus root 5, what we're going to get is root 5 times 1. That's going to be root 5 times 1 is root 5. All right. Root 5 times minus root 5, that's minus 5. Minus 1 times 1 is minus 1. Minus 1. And then minus 1 times minus root 5 is plus root 5. So I get plus root 5 here. Now in the denominator, you're going to get the difference of 2 squared. So you're going to get 1 squared minus root 5 squared. You're going to get 1 squared minus root 5 squared. The denominator becomes the difference of 2 squared. That's what happened when you multiply a plus b times a minus b. So simplifying, you're going to get root 5 plus root 5 is 2 root 5. So you get 2 root 5 minus 5 minus 1 is minus 6. So you get 2 root 5 minus 6 divided by 1 square minus root 5 square. That's 1 minus 5. 1 minus 5 is negative 4. Now, what you can do is factor out 2 over 4. Factoring out 2 from the numerator, you're going to be, well, factor out 2 from the numerator. All right, when we factor out 2 from the numerator, we're left back with root 5 minus 3. Root 5 minus 3. And So this is what we have, root 5. Why did I write root 3 here? This should be root 5. That's root 5 minus 3, and it is being divided by -4. All right. And so if you're to apply the -4 inside here, we're going to apply the -4 inside here. And so what you get is, or some people wouldn't bother to do that, they realize that this 2 cancels to become 1, cancel to become 2, and then put the numerator in here. And so what it works out to be equal to is, apply the negative inside this bracket. And so what you get is a half times, applying the negative inside, you get 3 minus root 5. 3 minus root 5. And so we look for a half of 3 minus root 5, which is option D. Nice. All right, question 16 is another indices question. It says 2 to the minus 1 divided by 8 to the 1/3 simplifies to b. Now 2 to the minus 1, remember, is a half. So they're saying a half divided by 8 to the 1/3. Now 8 to the 1/3 means the cube root of 8. 8 to the 1/3 means the cube root of 8. Now what is the cube root of 8? The cube root of 8 is 2. So they're asking you to find what is a half divided by 2. They want you to work out a half divided by 2. Nice. So a half divided by 2, and that is just going to be a quarter. All right, that's a PEP question, soft. That's a quarter. All right, moving along. So now we finally get to sequence and series. And this question says, in a geometric progression, each of whose terms is positive, they said the 5th term is 45 and the 7th term is 5. What is the 6th term? So first thing we have to remember is that any term of a geometric progression, we can call it Tn, is represented by a times r to the n minus 1. All right, that's how we find a term in a geometric progression. And so the 5th term would mean you plug in n as 5. And if n is 5, then that means we get T5, and they tell us T5 is 45. And so that means that 45 is equal to the first term, a, which we don't know, a times r, which is a common ratio, a times r to the n minus 1. 5 minus 1 is 4. All right? And so this is the 5th term. And they tell us that the 7th term is 5. So the 7th term, they tell us that 5 is equal to, this is now a times r to the 7th term is 7 minus 1 is 6. All right, so this is what we have. Nice. And so we can use this to find a and r and then find the 6th term. That's one way of doing it. So let's do our division. 45 over 9. 45 over 5 is 9. A divided by a cancel. R to the 4 over r to the 6 is r squared. So that leaves 1 divided by r squared. That is 9. And so that implies that r squared is equal to 1 over 9. R squared is equal to 1 over 9. If r squared is equal to 1 over 9, then r is the square root of 1 over 9. And so r is equal to the square root of 1 over 9, which is 1 over 3. So r is equal to 1 over 3. Since r is 1 over 3, we can plug it in any one of these to find a. Plug it in any one of these to find a, because r is now 1 over 3. So we have 45 is equal to A. All right, let's try to make some space. So what we're saying is A right here will be equal to 45 over R to the 4. 45 over R to the 4. But R is what? R is 1/3. So A is equal to 45 over 1/3 to the 4th power. So when you do that, that will give you the first term, and you get that the first term is 45 divided by 1/3 to the 4th power. I'm getting 45 divided by 1/3 raised to the 4th. 45 divided by that, I get 3,645. 3,645. That's the first terminal, that's not the answer. So now after you get that now you're able to find what is the 6th term. So the 6th term, remember, the 6th term is going to be equal to AR to the 5th. And so we need to work out AR to the 5th. So AR to the 5th is 3,645 multiplied by 1/3 to the 5th power. You put this in your calculator. 3,645 times 1/3 raised to the 5th power, and I get 15. Works out to be 15. All of this down here works out to be 15. Nice and easy, soft. Nice. So that is the 6th term. Now question 18. It says the sum of odd integers between 10 and 50. So if they want the sum of all odd integers, what they're asking you to find is the first odd integer is 11 plus 13 plus 15 plus 17 plus 19 plus all the way up to the last odd integer would be 49. Now, if you have time, you can sit down and add all these up. All right, 11 plus 13 plus, I keep on doing. Or you could realize the pattern. Realize this is a arithmetic progression with first term. So this is a AP, and realize that this is a AP with first term A equal 11, and it have a common difference D equal 2. And it have a last term of 49, L equal 49. So what does that mean? So the sum of all the terms, the sum is going to be equal to, as you can clearly see, how many integers is this going to be? So the sum is going to be 11. If the last term is 49, all right, the last term is 49, and there are 25 terms in this expression. There are 25 terms. There are 25? Let's check if there are 25 terms, because we need to find n. Before we can use the sum formula, we need to find n. All right, so remember, 49 is a plus n minus 1d. We just need to find how many terms are there. 49 is 11. A plus n minus 1 times d, n minus 1 times 2, so it works out to be 2n minus 2. All right, we'll bring over that to bring over 11. That's going to be subtracting 11, 49 minus 11 plus 2. I'm getting 40. I'm getting 40. All right, I'm getting 40 is equal to 2n, and I divide by 2, and I get n is 20. So there are 20 terms, all right? There are 20 terms. So pretty much we're finding the sum of these 20 terms, S20, and S20 is equal to n over 2. So it's 20 over 2 times A plus L, where A is the first term, 11, plus L. L is the last term, L is the last term, 49. And so we work that out. Nice. 11 plus 49 is 60. 60 times 20 over 2 is 10. 60 times 10 is 600. So that's option B. That's how we do that question. Soft. All right. Now let's look at this right here now. This says now the first four terms of a convergent geometric progression is given by 500, 200, 80, and 32. Find the sum to infinity of this GP. So to find the sum to infinity, sum to infinity is A over 1 minus R. So we need to find R. R is the second term divided by the first term, or some people might say 32 over 80. So R is equal to 32 divided by 80, which is the fourth term divided by third term. That simplifies to be 32 divided by 80 is 2 over 5. So the common ratio is 2 over 5. And so now the sum to infinity is A over 1 minus R. That's the formula for sum to infinity. And so in this case, sum to infinity is A, which is 500 divided by 1 minus 2 over 5. You put that in a calculator and you get your sum to infinity. 1 minus 2 over 5. And we have 500 divided by that. That's 833 and 1/3, which is 2,500 over 3. That's the sum to infinity. Soft. Question 20. Question 20 says, a long distance runner runs the first kilometer of a race in 3 minutes 45. That's not bad. 3 minutes 45 is decent pace. I can tell you that's 1,000 meters in 3:45. He's pretty fit. And it says now, but his speeds drop steadily so that each kilometer takes him 12 seconds more than the preceding one. Find the time taken to cover the first 12,000 kilometers. So for simplicity of this question, I like to work strictly in terms of seconds. 3 minutes and 45, I like to work strictly in terms of seconds. So that for me is 3 minutes is 180 plus 45, that's 225 seconds. All right, that's 225 seconds. Now, look at this now. So 225 seconds, that's his first kilometer run. All right, so if you're to list it out like a sequence, his first kilometer is 225, his second kilometer is 237, the next one would be 249, and so forth until he reach the 12th kilometer. And they want us to find the time taken to cover the first 12 kilometers. So to find the time, they want us to add it up. So first thing, we need to realize that the common difference is D because it's an arithmetic progression. The common difference is D. And so we need to find the time he take to cover in the 12 kilometer. The 12 kilometer. So we need to find when n is 12. When n is equal to 12, what you're going to get is the time he covered in the 12 kilometer. So I'm going to call that T12. The time he taken to cover the 12 kilometer is A plus n minus 1D. So that's 225 plus 11D. So it's 225 plus 11 times 12. 11 times 12. 225 plus 11 times 12, that's going to give me 225 plus 11 times 12. That's 357 seconds. Now that I have the time it took him to cover the 12 kilometer, then I can find now the sum. The sum is equal to n over 2. He covered 12 kilometers, so it's now 12 over 2 times a. So it's a plus L. A is your first term of 225. 225 plus 357. All right, so his speed drops significantly. So when you work out all of this, that will give you the sum. So 225 plus 357 times 12 over 2, which is 6, you get 3,492 seconds. So you're getting 3,492 seconds. Now remember that is seconds. This is seconds. So you have to divide it by 60 to get it in minutes. So dividing it by 60, I get 58 minutes and 12 seconds. So that's option A. All right, nice and easy. Soft. Remember this was in seconds. Nice. Question 21. Question 21 says the line 7x minus 4 and the line 3x minus y minus 5 intersect at P. Find out what is P. So they want us to solve this pair of equations simultaneously. So we have 7x minus 4y is equal to negative 25. All right, so I transposed it. And then I'm going to multiply this equation by, let's say 4. Multiplying this by 4, I would get 12x. Multiplying minus y by 4, I get minus 4y. And then multiplying minus 5 times 4, I get minus 20. And when I carry it over, it becomes positive 20. Now what I'm going to do is I'm going to subtract these two equations. Going to subtract these two equations. Let's go ahead and we subtract them. Now 7x minus 12x, that's minus 5x and minus 5x, and then we have minus 4y minus 4y 0, minus 20, minus 25 minus 20 is minus 45. And so in this case, x equal 9. In this case, x equal 9. Now you may proceed and find the y value, but there's only one option where x is 9, which is option D. Since we get x is 9, we can stop right there and say 922. To verify your answer, you can put x as 9 right here. 7 times 9 minus 4 times 22 plus 25. You're going to get 0. And you can put 9 and 22 right here, and you're going to also get 0. Question 22. Question 22 says the line through points K, 2 and 6, 8 is parallel to the equation this. And it says find the value of K. Now, if two lines are parallel, then we know that they have same gradient. So this line right here, if I make y the subject, it is telling me that y is equal to minus 3x plus 21. All right, minus 3x plus 21. So this is a line with a negative gradient. And so that means that the gradient of the line PQ, so the gradient of the line PQ, is negative 3. Gradient of the line PQ is negative 3. But we can find the gradient of PQ using y2 minus y1. So it's 8 minus 2, y2 minus y1 over x2 minus x1, which is 6 minus k, and that is negative 3. And so what we're getting is 8 minus 2 is 6. 8 minus 2 is 6. And so what we get is negative 3 is equal to 6 over 6 minus k. All right. And so what that means is we know that 6 over negative 2 is negative 3. And so that tells us then that 6 minus k is equal to negative 2. 6 minus k equal negative 2. And so k equal 8. K is 8. K equal 8. That's the value for k. You can check it. If you put k as 8, you would get 8 minus 2 is 8 minus 2. 8 minus 2 is 6. And then 6 minus 8 is negative 2. And so yeah, 6 over negative 2 is negative 3. So k is 8 for real. That's option C. No trouble at all. Moving right along. All right, question 23. We're halfway there. Question 23 says the point 2, 3 is at one end of a diameter of a circle whose equation is given by this. It says, find the coordinates of the other end of the diameter. First thing is you need to rewrite this in its standard form, and that allows you to find the radius. So if you were to rewrite this in its standard form, what you would get is, I'm going to rewrite it up top here. Let's make some space. Right here, you could complete the square for these two x terms, and that would become x. You divide this by 2, and so you get x minus 5 square, and then you subtract 5 square, which is minus 25, plus, then this now, you divide this one by 2 to get y plus 1 square, and you subtract 1 plus 1, and that's equal to 0. This is equal to 0. So in reality, what happens is the center looks like 5 minus 1. So that means the center is 5 minus 1, and the radius is 5. The radius is 5. All right, I'm going to put it in its standard form for us to see. So what we're ending up getting is x minus 5 square plus y plus 1 square, y plus 1 square, and that's equal to 5 square. This is now equal to 5 square. Nice. So since this is what we have now, we're good, we're straight, we're nice. So we can stay, so now, I'm just gonna draw some random circle so we get an idea of what is going on. Let's draw some random circle. And we now know that the center is 5 minus 1. That's the center. The center is 5 minus 1. 5 minus 1. That's the center. And then they give us one endpoint, which is 2, 3. 2, 3 could be somewhere right here. All right, this is the point 2, 3. All right. And we need the other end of the diameter. The other end of the diameter is going to be somewhere over here. Now look at this. Because the distance from here to here is going to be the same as the distance from here to here. So what am I saying? Looking at the x coordinates, you go from 2 to 5. And so the next place you go in must be 8. So the x value right here has to be 8. This has to be 8 because the distance from one end to the center is the same from the center to the other end of the diameter. So we know that the x coordinate is 8. This is for the x coordinate. For the y coordinate, you observe that it is going from 3 to negative 1. And so it must be going next to negative 5. It has to go to negative 5 next because you're going down by 4. So it is 8, -5, which is option D. All right, nice. Question 24. It says that the vector A is given as 5i plus 12j. What's a unit vector parallel to A? First thing, a unit vector, its magnitude is going to be 1 over 5 squared plus 12 squared. This is the magnitude of the unit vector, 1 over 5 squared plus 12 squared. And 1 over 5 squared plus 12 squared square rooted is 13. It's going to work out to be 1 over 13. And since we're getting 1 over 13, then this is a unit vector parallel to it. Well, no, that's not it. That's 3 over 13. We need 1 over 13 for the magnitude, which is this. This is a unit vector. All right, now this says now, given that OA is this and OB is this, find vector AB. So to find vector AB, we have to remember that vector AB is OB minus OA. Always remember that vector AB is equal to OB minus OA. That is vector AB, OB minus OA. Since vector AB is OB minus OA, then what that means is vector OB is going to be 4, 5. This is 4, 5 minus OA, and OA is minus 17, 25. Minus 17, 25. And so what you get is 4 minus 17 is 21. And 5 minus 25 is minus 20. So it's minus 21, 20. Minus 21, 20. That looks like option C. Minus 21, wait, 21 minus 20, that's option D. My apologies, option D. Option D. Let's clear out this right here, not C. So you have to remember that vector AB is vector of the last minus vector of the first. All right, so that's how we get that. Nice. Now, right here now they said the position vectors of A and B relative to the origin are 2, 5, relative to the origin, where A is 2, 5 and B is 3 minus 1, find the acute angle. So I always like to give a little picture up here. So we have the origin right here. And so what you have is vector 2, 5. That means x is 2, y is 5. Let's put 5 here. So right here, so would be vector A. And then you want, so this would be vector OA from the origin to A. Vector B is 3 minus 1. So let's put 3 right here and minus 1 right here. And so this would be vector B. All right. And so this is vector OB. Yeah, man. And so this would be the triangle OAB. And what they want is angle AOB. AOB, which is the angle right here. This is the angle they want. All right. So to find angle AOB, we need to find, we're going to use dot products to find the angle. So this angle right here. So first thing we have to remember is that the cos of the angle, I'm calling it theta, is equal to A dot B over the magnitude of A times the magnitude of B. That's how we're going to find cos of the angle. Now A dot B is 25.32. So 25 vector 25 dot vector 3 minus 1. So find this dot product and it works out to be 2 times 3 is 6 plus 5 times minus 5 plus 5 times minus 1 is minus 5. And so that works out to be 1. So we get 1. Now we need to find the magnitude of A. The magnitude of A is going to be equal to the square root of 2 square plus 5 square. So we get 2 square plus 5 square. 2 square plus 5 square is 25 plus 4, and 25 plus 4 is 29. And so the magnitude of A is the square root of 29. Next thing we need is B. And so what we're getting then is B is the square root of 3 square plus 1 square, 3 square plus 1 square. And so 3 square is 9 plus 1 is 10, square root 10. That's not the square root of 10. Nice. And so that means A times B, if you were to multiply them, would actually give you the square root of 290. Yeah, man, so good. And so it's going to be cosine inverse. A dot B is 1. So A dot B here, 1. Nice. So just to make some space now, I'm going to take off this part just to make some space. So what we're getting now is from right here, we're getting that the cos of the angle, the cosine of the angle, the cos of theta, we're getting that is A dot B, which is 1 over the square root of 290. That's what we're getting. Cos of theta is 1 over the square root of 290. 1 over the square root of 290. That's right here. Nice. Now here's this question, question 27. It says if the sine of theta is 5 over 13 and theta is obtuse, what is tan theta? The best thing to do is to draw a triangle. Obtuse means the angle is in the second quadrant. And so just draw a triangle in the second quadrant. I don't care how you want your triangle to look. I'm going to put a triangle in the second quadrant. All right. And just obtuse mean angle is in the second quadrant. So I'm just going to put some triangle in the second quadrant like this. And the opposite is 5. The hypotenuse is 13. All right. Let's call this our theta. Now, since we're in the second quadrant, obtuse mean here in the second quadrant. Now, what is tan theta? We need to find the adjacent. Now, the adjacent is going to be minus 12. All right, the adjacent is minus 12. Why is it minus 12? We're in the negative x right here in the second quadrant. And so the tan of theta is going to be equal to opposite of 5 over adjacent negative 12. So that's how we get B. All right. Question 28. Question 28 says we need to work out what this is. Now we're going to use compound angle formula to do this. So remember, so now we have the cos of A plus B plus the cos of A minus B. Now the cos of A plus B, that's going to be equal to cos A cos B minus sine A sine B. That's the first part. Then we have plus cos A cos B, and then when it's a minus it becomes plus sine A sine B. Now notice what happened. What did happen? What happened is minus sine A sine B and plus sine A sine B cancel. And so you're left back with cos A cos B plus cos A cos B. And cos A cos B plus cos A cos B is 2 cos A cos B. So you get 2 cos A cos B. And that's option D. That's question 28, soft. All right, question 29. Question 29 asks us to sketch the graph y equals sine 2x. So to sketch the graph y equals sine 2x, well, first, we know that the sine graph passes through the origin, but look at this now, sine 2x. We need to find when is sine 2x equal to 1. All right. So my preferred method is for you to actually put a table. I'm going very basic. I like when you put a table. All right, you might say, sir, what table? Why do I need a table? Well, you're going to see. It's easier when you have a table and you have your range, your domain. So X, so you can have your X and your Y. So up here we have our X values, and down here we can have our corresponding Y values, which is Y equals sine 2x. Now the graph they want is between 0 and pi, so I'm going to put in 0, then I'm going to go pi by 4. Let's go 0, pi by 4, then we can go pi by 2, then we can go 3 pi by 2, and then we can go, no, not 3 pi by 2. Final value, we can just go to pi. Let's just observe these values. When x is 0, sine 2x is 0. When x is pi, sine 2 pi is pi. So those two are 0. Let's check what happens at pi by 2. When x is pi by 2, we're getting pi by 2 times 2, and the sign of that is 0. So you're also getting 0 right here. Now when x is pi by 4, what you're going to get is, when x is pi by 4, you put pi by 4 here. 2 times pi by 4 is pi by 2, and the sign of pi by 2 is 1. So we need to see which graph best suits this data. Let's see, 0, x is 0, 0, this is good. X is pi by 4 right here, you get 1. Pi by 2, you get 0. Pi, you get 0. That's option A. So that's option A. We didn't have to go far. It's option A, and we're good. Moving along. Question 30. Question 30 says, the smallest positive angle for which sine theta equals cos theta. All right, so we need to solve sine theta minus cos theta equals 0. Now what I would do is I would divide both sides by cos theta. Divide everything by cos theta. If I divide the entire equation by cos theta, what I'm going to get is sine over cos theta is tan theta. Then cos theta over cos theta becomes minus 1. And 0 divided by cos theta is equal to 0. So that's all I did, divide by cos theta. And since I divide by cos theta, I can bring over the 1, and so now I get tan theta is equal to 1. And since I get tan theta is equal to 1, then I can take tan inverse to find theta. And so theta is equal to tan inverse of 1, and tan inverse of 1 is equal to, tan inverse of 1 is pi by 4. And that's finished. So tan inverse of 1 is pi by 4. So that's the smallest value of theta to satisfy this equation. Moving right along. Now this right here asks you to expand the sine of alpha plus 45. To expand this, we have to remember the identity that tells us that this is the sine of alpha plus 45 is given by, sine A. So it's given by sine alpha So this is going to be equal to sine alpha times the cosine of 45, sine alpha times the cosine of 45 plus the cos of alpha times the sine of 45. Cos of alpha times the sine of 45. Now, after you do this now, what are you going to get? Well, what we get is the cos of 45 is 1 over root 2. So you're going to get 1 over root 2 times the sine of alpha. That's what we're getting. And then over here, what we get is cos alpha times sine 45, which is the same, plus 1 over root 2 cos alpha. Now, since both of them is going to have 1 over root 2 in common, we're going to factor out 1 over root 2. And so it will give us 1 over root 2 sine alpha plus cos alpha. Nice. Now, this question says convert this into radians. Convert this radians into degrees. Now, remember, pi radians is 180. So replace pi with 180. That's all you have to do. And so you're going to get 4 over 5 times 180. 4 over 5 times 180, that is equal to 4 over 5 times 180, that's 144. That's 144 degrees. That's option B. All right. Moving along. It says find the exact value of the tan of 150 degrees. To find the exact value of the tan of 150 degrees, well, that's quite simple. What do we do? Well, to find the exact value of the tan of 150 degrees, work it out. Tan 150, you can put it in your calculator. All right, but remember, there's what's known as equivalent angle. So I'm going to draw my circle right here. And remember, they taught us that all schools teach crap. All schools teach crap. Tan is positive here, and tan is positive here. 150 degrees is going to be in the second quadrant. 150 is somewhere here. So we're in the second quadrant. So if we're in the second quadrant right here, and this is 150 degrees, this is where tan is negative. All right, this is where it is negative. So tan is negative. So tan 150 is negative. Automatically, we know that tan 150 is negative. But let's first find the principal acute angle. So remember, this is pi minus, or 180 minus. So the angle in the first quadrant is going to be 30. So what am I saying? I am saying that the tan of 150, is equal to negative the tan of 30. Thank you, Lord. This is so easy. So we have negative the tan of 130. And so you work out what's tan 30. Some people might call 30 pi by 6. Pi divided by 6. So negative tan of 30 is, that looks like negative 1 over root 3. Negative 1 over root 3. Nice. Okay, moving right along. It says the trigonometrical expression sine x over 1 minus cos x plus sine x over 1 plus cos x is identical to. First, when you're solving this question, you need to write it as one fraction. So you find the LCM. So find the LCM. Write it. The LCM is going to be 1 minus cos x times 1 plus cos x. That's the LCM. 1 minus cos x times 1 plus cos x. That's the LCM. 1 minus cos x times 1 plus cos x. Nice. Now, 1 minus cos x into this leaves 1 plus cos x. And so we get sin x times 1 plus cos x in the numerator. So in the numerator, we're getting sin x times 1 plus cos x. And then we have plus, we're going to say now sin x into this leaves sin x into this denominator leaves 1 minus cos x. And so what we get in the numerator now is sin x times 1 minus cos x. Good. So that's what we're getting so far. So far we're good. Yeah man, so far we're good. So far we're good. This is what we get in the numerator. Now, as you can see right here in this numerator, if you factor out sin x from the numerator, factor out sin x, you're going to have 1 plus cos x plus 1 minus cos x. 1 plus cos x plus 1 minus cos x. That's what you're going to have if you factor out in the numerator. Now, look what is going to happen in the denominator. In the denominator, 1 minus cos x times 1 plus cos x is 1 minus cos squared, because it becomes a difference of 2 squares, so you get 1 minus cos squared. Now 1 plus 1 becomes 2, cos x minus cos x cancel, and so it becomes 2 sin x, so we get 2 sin x over, now 1 minus cos square is sin square, and so you get 2 sin x over sin square x. But then a sin x from the numerator cancels a sin x from the denominator, and so you get 2 over sin x. And so that is the answer, 2 over sin x. Option C. All right, question 35, we reach differentiation now. It says, given that y is 5 minus 2x to the 5, differentiate it. So if y is this, dy by dx, dy by dx is carried on the power. Dy by dx is going to be carried on the power of 5. Subtract 1 from the power, so you write back what was inside the bracket of 5 minus 2x. But then 5 minus 1 is 4. Then you multiply it by the derivative inside the bracket, which is negative 2. And 5 times negative 2, that is just negative 10. So we get negative 10 times 5 minus 2x to the 4th power. Negative 10 times 5 minus 2x to the 4th power. That's what we get. Negative 10 times 5 minus 2x to the 4th power, which is option A. All right. It says the gradient at x equal pi by 6. So first thing you need to do is differentiate sine x. When you differentiate sine x, when you differentiate sine, you get y prime. Y prime means dy by dx. When you differentiate sine x, you're getting cos x. But they want the differential when x is pi by 6. So it's going to be the cos of pi by 6. So we find the cosine of pi by 6. And the cosine of pi by 6 is cos of pi by 6. That's root 3 over 2. Nice. That's the gradient. Nice. Now this question says, question 37, the equation of a curve is given by this. Find the gradient function. Now notice that this is the product of two functions, and so you learn that the differential is v du plus u dv. So dy by dx is going to be equal to dy dx is equal to, many people learn it as, this is your u and your v, it's v du. So write back your v first. So it's x minus 1 cube times du is the derivative of x squared plus 2, which is 2x. So that's v du plus u dv. U dv, your u is x squared plus 2. So you have x squared plus 2. That's your u times your dv. Your dv in this case, dv is going to be carried down the power, subtract 1 from the power. So dv is going to be 3 times x minus 1. 3 times x minus 1, subtract 1 from the power square. Now, what do you notice? We notice that they have a common factor of x minus 1 squared. So we can factor out x minus 1 squared. And so what are you going to be left with? When you factor out x minus 1 squared, we're left back with x minus 1 times 2x. So you're left back with x minus 1 times 2x. And then what are you left back right here? You get plus, factoring out x minus 1 squared from over here, we're left back with x squared plus 2 times 3. We're left back with x squared plus 2 times 3. Nice, soft. And so what we're getting is dy by dx is equal to x minus 1 squared times, now in here becomes x times 2x is 2x squared. 2x times minus 1, that's minus 2x. 3 times x squared is 3x squared. And then 3 times 2 is 6. Now what do I want you to observe? 3x squared and 2x squared is 5x squared. And so that looks like option C, 5x squared minus 2x plus 6. That's option C, soft. Question 38. Given that this is y, find dy by dx. So we differentiate this now. Y is 5 sine 2x. When you differentiate sine, you get cos. So you get y prime or dy by dx. You get y prime is equal to, you differentiate sine, you get cos. And so you get 5 times cos 2x. And remember, you multiply it then by the derivative of 2x, which is 2. And so when you multiply it by 2, you get y prime is equal to 2 times 5 is 10. And so you get 10 cos 2x. 10 cos 2x. Nice, that's what we get, 10 cos 2x, which is option D. Now, question 39. Question 39 says, the curve C is given by the equation y is equal to x squared plus 16 over x. Find the second derivative d2y by dx squared. So they tell us that y is equal to x squared plus 16 over x. And we can rewrite 16 over x as 16x to the minus 1. And so we can find y prime, which is the first derivative. The first derivative is 2x. Carry down the power, subtract 1 from the power, minus, carry down the power. So it becomes 16x to the minus 2. Yeah, man, 16x to the minus 2. And so the second derivative, y double prime, is equal to, when you differentiate 2x, you get 2. You carry down the minus 2 now to get plus 32x to the minus 3. But remember, x to the minus 3 is 1 over x cubed. So we have 2 plus 32 over x cubed, which is option B. Nice. Let's look at question 40. Question 40 says, find the value of a for which the integral from 0 to a of x squared minus 5 is 50 over 3. So when you integrate x squared, you're going to get x cubed over 3 minus, when you integrate 5, you get 5x, right? And you're integrating from 0 to 3. From 0 to not 3, to a, my apologies. And that is equal to 50 over 3. Now what you do is you plug in x as a, and so what we're solving is a cubed over 3 minus 5a, a cubed over 3 minus 5a is equal to 50 over 3. So this is what we're solving. Now, you can write this as one fraction. That's what I would do anyways. I would rewrite it as a cubed minus 15a over 3. And that's equal to 50 over 3. Now, when you have a fraction where the numerator and the denominators are equal, right? Then we can throw away the denominator pretty much. So let's throw away the denominator. So what we end up solving is a cubed minus 15a is equal to 50. A cubed minus 15a is equal to 50. All right. Now you could go ahead and use trial and error and solve this, but my suggestion would be for you to try values for a and see which one will give you 50 now. So for example, 5 cubed minus 15 times 5, that's 50. The first one give me 50. So I say when I put in a as 5, that will give me 50. And so a equals 5. Instead of making a cubic equation and solving a cubic, we don't need to be doing that. Let's try the values now. And so a equals 5. Try the value a in this equation. Nice. Question 41. Obtain the integral of this. So remember, to integrate, we add 1 to the power. So it becomes 3x minus 5. We add 1 to the power, which becomes 5. Then we divide by the new power of 5. Then we multiply it by the derivative of what's inside the bracket, which is 3. 5 times 3 is 15. And so it becomes 3x minus 5 to the 5 over 15, which is option C, soft. All right. Now this question says, the region in the first quadrant enclosed by the curve y equal x minus a half x squared, and the lines x equals 0 and x equal 2 is rotated about the x-axis. Find its volume. You have to remember that the volume is equal to pi times the integral of y squared dx. That's the formula for volume. Pi times the integral of y squared dx. Now, the integral of y squared dx. Now, find what is y squared first. So I noticed that y squared would be equal to x minus a half x squared. So square this. X minus a half x squared. A half x squared, and then we're squaring all of this. When you square all of this, what you're going to get is first term square, which becomes x squared, minus twice the product of the 2. And if you don't know to expand this way, you can write it as x minus a half x squared times x minus a half x squared. All right. So all we're doing is expanding this bracket. So that's what we get. When I multiply this now, x times x squared is x cubed over 2 times 2. That becomes just x cubed. So I get x squared minus x cubed plus a half x squared is going to be a half square is a quarter x to the 4. So that's what I get for x squared. So that's what is y squared I mean. So volume now is going to be equal to pi times the integral of all of this. So now we're integrating x squared minus x cubed plus x squared over 4. X to the 4 over 4. All right, now when I integrate all of this, what am I going to get? I'm going to get pi times, when I integrate x squared, I get integrate x squared, it becomes add 1 to the power x cubed over 3. It becomes x cubed over 3 minus, when I integrate x cubed, I get add 1 to the power x to the 4 over 4. When I integrate x to the 4 over 4, I get add 1 to the power becomes x to the 5th over 5 times 4 is 20. I get plus x to the 5th over 20. Shouldn't have been writing it right here. Oh God, I want some more space. All right, need some more space right here. Don't want to get over to that side. All right, don't want to go over there. All right, so we already worked out what was y squared, so I'll erase this down by the bottom. I can do that to make some more space. Now this looks a little better, a little more space, so the volume is equal to pi times, and we were integrating now, and we were getting x cubed over 3. We were getting minus x to the 4 over 4. And we were integrating and we're getting x to the 5 over 5. Nice and easy, soft. And we're integrating from 0 to 2 because those are the lines it is bounded by. So we're integrating from 0 to 2. So all you need to do is you don't need to plug in 0. And it was 5 times 4. 5 times 4. This dot means 4. Or let me put a bracket. You're probably used to seeing bracket for times. So that's equal to, plug in x as 2. We get 2 cubed divided by 3. So plugging in the 2's, we're getting pi times. We're getting 2 cubed is 8 over 3. Plugging in 2 here, 2 to the 4 is 16. 16 over 4 is 4. We'll get minus 4 plus, plugging in 2 as x here, 2 to the 5th is 32. So we're getting 32 over 20. So you put all of that in a calculator and simplify it. I can't do this out of my head for now. 8 over 3 plus 32 over 20 minus 4. I get 4 over 15. So it's this, 4 over 15 times pi. Nice, that's the volume. Question 43. Question 43 says the region R is enclosed by the x-axis and the curve x squared plus 2x from 2 to 3. Find the area. And the area is R. The area R is just going to be equal to the integral of y dx. That's how you find area. And so R is equal to the integral from 2 to 3 of y, and y is x squared plus 2x minus 1. Now I'm going to continue it up here. I'm going to finish it off up here. So when I integrate, I get x cubed over 3 plus x cubed over 3 plus 2x integrated, that's going to give me 2x squared over 2, which is just x squared, minus, when I integrate 1, I get x, and you're integrating from 2 to 3. So when I plug in 3, plug in 3, I get 3 cubed divided by 3, 3 cubed divided by 3 plus 3 squared minus 3, and that part gives me 15. So I have 15 minus, when I plug in x as 2, I get 2 cubed divided by 3 plus 2 squared minus 2, and I get 4 and 2 over 3. So it's 15 minus 4 and 2 over 3. And when I work that out, that is 31 over 3. Let's put that in a calculator. 15 minus that, you get 31 over 3. Nice. Now this now asks us to integrate this. The integral of sine, when you differentiate sine, you get cos. And so when you integrate sine, you get minus cos. When you integrate sine, you get minus cos. You get minus cos x. Now when you integrate cos, you get sine. So you get plus 2 sine x plus some constant. Okay. All I did was rearrange the order and put the 2 sine x to the front. And so you get 2 sine x minus cos x plus c. Option A. Nice. Now this question says, given that the differential of this is 1 over 1 plus x squared, find the integral of 3 over 1 plus x squared. Now look at this. The differential of this is equal to this. I think I'll need some more space to do this. So let me go around here so it makes a lot of sense. This final question. So they told us that d by dx of, they told us that the derivative of x over 1 plus x is 1 over 1 plus x squared. So the derivative of x over 1 plus x, they said that the derivative of this is equal to 1 over 1 plus x squared. Was it 1 plus x squared? Let me see it one more time. 1 plus x all squared. So that's what they tell us. 1 plus x all squared. Now look at this now. Now since the derivative of this is equal to this, differentiation and integration, they are inverse of each other. And so what that means is, they're inverse process of each other, or they're reverse process of each other. That means that if I were to integrate both sides, then what that means is the integral cancels d by dx. The integral cancels d by dx. Example, look at this. Example, look at this. Y equal 5x, right? If y is 5x, when you differentiate 5x, you get 5. The derivative is 5, right? But if you go ahead and integrate back y prime, when you integrate back y prime, you integrate y prime, you get y, and you integrate back your 5x, you get back, integrate 5 to get back your 5x. All right, and so the integral cancels the derivative. All right, integral cancels the derivative. And so what that means is that the integral of 1 over 1 plus x squared The integral of 1 over 1 plus x all square, that is equal to x over 1 plus x. Good. Now the question that they were asking you to do now is hence find the integral of 3. So hence they wanted to find now the integral from 0 to 2, I believe, of 3 over 1 plus x all square. So the integral from 0 to 2 of 3 over 1 plus x squared. Now, if you notice from up here, if you were to put a 3 right here, if you were to put a 3 right here, or if you were to just multiply both sides by 3, multiply this by 3, you get that 3 times the integral of this is equal to 3x over 1 plus x. And so this is what we have now. So we have 3x over 1 plus x, and you're integrating from 0 to 2. That's what we have. And now we're integrating from 0 to 2. So you plug in x as 2 first, you get 6 over 1 plus 2 is 3, minus you plug in x as 0, you get 0. And so 6 over 3 is 2. All right? So that works out to be 2. Here it is, 2. And this concludes 2012 paper 1. Very easy, soft with a capital T. All right, I wish you all the best prepping for your exam. Soft.